All right, class, today we're continuing on with section 1.1, points, lines, and planes. In the previous notes, we looked at the definitions, and today we're going to look at some examples. So example number 1 in your note packet says, name 4 coplanar points. So if we look at this figure, we have a point at A, at B, C, D, and E. Which 4 are coplanar? All on the same plane, and that would be A, B, C, and D. So points A, B, C, and D are coplanar. Those are the only 4 that are coplanar with each other. However, if we look at E, C, and B, those are also coplanar. And if you remember, a plane only needs to be identified by 3 points. So 3 coplanar points make a plane. So E, C, and B would also be a plane. But since A is asking for 4 coplanar points, we went with that. We could also look at A, B, and E, D, E, and A, D, E, and C. Those are all planes as well. All right, letter B, name 3 lines. So we could go from point B to point E, that would be a line. Remember, we name our line with the letters and the line with the arrows above it. E to C or C to E, either order. That would also be a line. D to E or A to E. So there are other possible answers as well. Like I said, A to E would be a possibility. And you could also flip the names of any of these. EB, EC, ED. That could be as well. And really even, you could extend out A and B to be a line, or any of those on that base. But I stuck with the ones that went up to E, since we do have the arrows going both directions on those, indicating a line. Example number 2, we need to name a line that passes through 2 points. So we see a line drawn through X and Y, and we just need to name that line XY. Or line YX. Example number 3, we need to name a plane that contains 3 non-collinear points. Remember, non-collinear is points that are not in a line. So 3 points not in a line. We have G, H, and F. And we just need to name that plane. So we have that little R. So it could be plane R. And we can also name our plane with the 3 points. So plane GHF. Example number 4, we need to sketch 2 lines intersecting in exactly 1 point. Well, anytime you have two lines that intersect, they're going to intersect at exactly one point. Next, for B, sketch a figure that shows a line that lies in a plane. So think about that for a moment. Think about how you could sketch that. Try it out on your own. Sketch a figure that shows a line that lies on a plane. And if you need some extra time, just pause the video. All right, so first we would need to draw a plane. So that'll be my plane, and then a line that lies on the plane. So a line that's on that plane. C, sketch a figure that shows two lines intersect in one point in a plane, but only one of those lines lies in the plane. So go ahead and pause and try and figure that out. So you would need to have a plane, and then we need two lines that intersect one another at one point, and that point being on the plane, but only one of the lines on the plane. So let's say here's where our lines are going to intersect. Maybe I've got, this is extending below the plane. So that would be two lines intersecting at a point that is on a plane, in the plane, but one of the lines not on the plane. Example number 5. You are given an equation of a line and a point. Use substitution to determine whether the point is on the line. So go ahead and pause the video, solve that on your own. All right, if we need to use substitution, we see this point. Our first value is our x value. Our second is the y value. So we can plug those in. We get 8 equals 5 times 1 plus 3. So 8 equals 5 plus 3. 8 equals 8. So yes, the point is on the line. So we're able to take that point, plug it into our equation of a line. If it comes out equaling properly, then we know that that point does sit on that line. All right, next you try. So go ahead and pause the video, work through each of these, and then unpause to see the solutions. So number 1, 2 opposite rays. We just need to name 2 opposite rays. So it could be ray CD and ray CB. That would be here and here. We had to use those because our vertical line, we don't know a point on the other ray. Then with number 2, a point on BC. So look at line BC. and we need to identify another point on that line. So that is D. D would be another point on line BC. Go ahead and call that point D. Number 3, the intersection of plane N and plane T. So looking at the intersection of two planes is going to be a line. And that line is our blue line there. Line BD. That's our intersection of the two planes. Line BD. Then number 4, a plane containing E, D, and B. E, D, and B. I think I called it plane T earlier. Whether this is a T or a J, we can go with it. All right, it's a T here, so we'll stick with T. So plane T. All right, then you need to draw each of the following. So go ahead and pause if you didn't already do those. And then drawing each of the following. A line intersecting a plane at one point. So we have a plane. And we need a line intersecting that at one point. So if I draw my vertical line, that would be a good example of that. And then number 6, a ray with endpoint P that passes through Q. So if it has an endpoint of P and passes through Q. All right, and that's what we have for 1.1 day 2. Your assignment 1.1 should be posted on Schoology. So go ahead and start working on that. Have a great day.